morning to one and all. On behalf of Department of Computer Science and Engineering, C. Abdul Hakim College of Engineering and Technology, I welcome everyone to today's webinar session. Today's webinar topic is Natural Language Processing and Its Applications, which will be presented by Ms.Niharika Krishnan. Now, I'll introduce our presenter, Ms.Niharika Krishnan. She is currently working as a machine learning engineer at TCS and has an undergraduate degree in information technology from SRM University, Chennai. She was the youngest speaker at the PyCon Canada conference in Toronto last year, where she presented a research work on understanding autistic children using biosensors and Python. She is the founding member and organizer of the PyLadies community in Chennai and has been an invited speaker at Google Women Tech Makers, PyOhio, and global diversity conferences. She has a passion for AI and believes in leveraging technology to help people lead better lives. Now, I'll hand over the session to Ms. Niharika Krishnan.
Thank you.
Thank you, ma'am.
Thank you so much for your introduction.
Yes, ma'am. Thank you, ma'am.
And thank you for having me take this session. It's really a very great opportunity, sir. So thank you to the college and thank you, sir. Okay, so I can share my screen, sir, and with that we can get started.
Okay, ma'am. Okay.
So is my screen visible?
Okay. Shall I share your screen, ma'am?
Yes, sir. So I can start, sir?
Yes, ma'am. You can start.
Okay. Hi, everybody. Thank you for joining. And today we'll be talking about natural language processing and its various applications, and we'll also see about how we can implement some of the techniques which we are going to learn today. So, Sir has already introduced about me, but here is just a few things about. So, I currently work. I graduated last year from SRM University, that is in the year 2019, and it's been a year I'm working in TCS. And off work, I love to contribute to the tech community as a speaker, mentor, promoting women Python enthusiasts to come and work together on open source projects. And with that, I think we can get started for today's session. So just to give you an overview of what to expect in today's session, the first part will be like a tech talk where I'm going to introduce what exactly is natural language processing. So this will be a beginner level talk where you will get introduced to the whole concept of NLP, how it fits into machine learning AI, how it fits into this whole family, and what are the basic, if one needs to get started, what are the techniques, what are the tools, what are the Python packages, and also what are the applications which we see around us. And along with that, we will take up a very common use case of sentiment analysis on an IMDb movie data set as to how we can leverage natural language processing and how we can come up with predict certain reviews, whether it's a positive or negative. And if time permits, we will also explore a little bit about what are chatbots, since this is something which I have been working for the past a year or 1.5 years, and it's one of the easiest and the most common place where we are using NLP in all kinds of forms, right? So we will also touch up a little bit on the chatbots if we do have time before the session ends. So with that, I think we can get started. So before we get into natural language processing, right, the whole concept of this starts from the word as cognitive computing. Now, what exactly is cognitive computing? If the word might sound, it's such a thing, but it is very simple. Like when I was a kid, or when anybody was a kid, this is just a small, short example which I always take when I explain to somebody what cognitive computing is. As a kid, we don't know language, we don't know how to walk. We all learn through trial and error. You are running one fine day, you hit something, you hit a wall, and then you realize, as a child, you realize, okay, this is not the way I'm supposed to go. So, two or three times later, what you do is your brain understands, involuntarily that this is, if I walk in this direction, I'm going to get hit. So the child automatically learns and moves in the right direction, right? So a child who is 3 years old or 4 years old, who knows nothing about cognitive computing, who knows nothing about natural language processing, how is the brain able to understand, learn from what he has seen in the previous 1 or 2 days, and then make informed decisions? So this is exactly what we now, all of us, all developers, researchers are trying to do. We are trying to mimic the way our human brain functions. So this is something which all of us have learned in our school days also, and this is something which our brain has been doing for the past, ever since humans are there in this world that is almost 200,000 years and counting. So our brain is able to do all of this. It is able to plan, problem solve. We are able to speak, smell, hear. These are all various sensory inputs, facial recognition, vision. So if you actually see, for all of you who are already aware of what machine learning, artificial intelligence does, is one by one we are trying to mimic what our brain does. So we initially started with concentration, planning, problem solving, as simple as calculators. We first started automating something with where you need, it's a rule based engine where you know that a plus b is equal to c. So those are the things we first initially, so many years back, humans were able to mimic using computers. Gradually, we then move towards, so when you talk about different fields in AI and machine learning, you have speech recognition, you have robotics, you have facial recognition, which is very prevalent, you have vision, which is basically computer vision. Reading is where we are going to focus today, which is natural language processing, language and reading. So if you actually see, what we're doing is what our brain has been doing for the past 200,000 years. We are coining it as the term as artificial intelligence, and we are doing the same thing, but for the last 70 years. So that was the first time we knew that we could actually mimic how our brain functions. So today we will be focusing on the NLP part of it and how it falls inside this entire structure of artificial intelligence. So we all hear AI versus machine learning versus NLP. There is data science. There are so many technologies, so many terms. But what exactly are they? Are they different? Are they similar? Are they a subset of each other? So just to put in a nutshell, artificial intelligence is, teaching systems to do the way humans behave. In a very simple term, mimicking how our human brain functions. Machine learning is when you can do the same thing and it will learn from experience. So that child, as a young child, when it learns that if I walk in this particular direction, I'm going to hit a wall. So 2 days later, 3 days later, when it moved to the right direction, it understood and it learned from experience. So it processed the data, it could understand what are the hindrances, obstacles, and then it learned and then it took the right path and made the right prediction. So that is where machine learning comes in. And if you focus on natural language processing, so this is something which has really come up recently. So language is there everywhere, right? Language is there in the way we communicate. Language is there in television. You have video. You can hear, you can read, you can see. So everywhere there is language, and in fact there are, I think, thousands and thousands of languages in the world. Each language has its own dialect and everything. So when you teach your system, and if you can capture this data and this particular language data, there's so much of inferences and analytics which one can do. And this particular small set where we are going to teach the systems to be intelligent and where they can understand what humans are trying to say, both in terms of text and speech, is what we call as natural language processing. So, to get into the more technical aspects of what really is natural language processing is, so main things. Whenever we come across language, whenever we do, the first thing we do is read, write, listen, and understand, speak. So that is exactly what we need to mimic the computer to also do. It should be able to read a particular language. This it should be able to decipher, understand, and make sense. So it is both. It is computer science, it is artificial intelligence, and it is also computational linguistics. Now, we're all, since we are in the academia, I felt this is a very apt example. So, if you see this particular graph, which is here, it shows the number of artificial intelligence papers, that have been published till the year 20 till nine from 1998 to 2017. So, if you see this graph, what you can see is, let's say, the blue one, which is here, which is machine learning and probabilistic reasoning, is really high. That is, the number of papers which are researched are very high, followed by neural networks, followed by computer vision. But if you see, NLP and knowledge representation is here, which is on a lower side as compared to other aspects of the other concepts which are involved in artificial intelligence. So why does this happen? Why is it that NLP is why are there less research papers which have been put forward in NLP? Is one reason is so okay. So when I explain to you, there are four things here which I will explain, and then can talk about how each one is. So there are the standard, non-standard examples. There is phonetics, there is unstructured data, and there is a lot of ambiguity. So earlier I spoke about there are almost let's say thousand or so many thousands and thousands of languages in the world. Each language has its own dialect. Each language has its own script. Every language, there is the grammar differs, the syntax differs, how you the active, passive, the way you structure a sentence differs. In fact, English itself is called a funny language because you really can't translate word by word, right? So when you have so much of so many different types of languages, it becomes very, very difficult to come up with one standard set of rules or predictions. And that is why NLP, compared to all other fields of artificial intelligence, is very, very difficult, and you see such so less papers that have been published. So here, if you see these four examples, which are very apt. So if you see standard, non-standard examples, this is all of us use this. Am not, is not, is all there. There are short forms which all of us use in our day-to-day life. But how will you, when I say very good, you can also mean, when I say cool, oh, this is such a cool slide. You will know that the author means it in a very positive way and not the literal meaning of cool. So, how will you make the machine understand this difference? We understand. We know if I'm saying that I'm pulling one's leg, we know it means that that person is trying to play a trick. But a machine will take the literal meaning of pulling one's leg, which doesn't make sense when you talk about playing a trick, right? So these are some standard, non-standard examples where the machine will fail to understand. Another very common use case which in NLP is phonetics. When I'm talking to a chatbot, let's say Alexa or Siri or a Google Assistant, I will say I need an ice cream, but it also sounds as if I am screaming. So you see, there is a very slight difference, and there are words like break and break. So these are all words which sound the same but have two very, very different meanings and can be used in very different contexts. So your machine should understand when to use what, which break has been used, and where. So this was one more example just to make you understand as to why NLP is so hard. The third one is, which you see there, is unstructured data. Now, there is no fixed, if you take an Excel file, you have rows, you have columns. If you take numbers, any language, be it or in any country, be it here, be it abroad, one means one and two means two. There is no second doubt about it. And always one plus two will always be equivalent to three. So it is very structured. So it is not independent of, it's not dependent of any particular language, right? Whereas if you see unstructured data, you have dictionaries, let's say, you have encyclopedias, you can have language in newspapers, in televisions, and every book has its own structure, every book has its own way of writing. So if you need to understand everything which is there in these books, that is a lot of unstructured data. And to convert this unstructured data itself into structured data is a huge, huge task. even in the industry. So, in fact, 90% of people, NLP based applications, a lot of time is spent on converting, let's say, doctors' prescriptions or certain handwritten notes or just any bill invoices. All of it, if you want to convert an encyclopedia into something which is digital, or you want to do some summarization, it is a lot of data which is in the form of unstructured. The next is ambiguity. So this, I think this example is pretty self-explanatory, where somebody is saying, call me a cab, and we all know, humans understand that when you say call me a cab, it means you want to hire a taxi, and book a taxi. But the machine will just take it in the literal meaning and make map that person's name as cab. So we need to, these are all the different places, especially in English language, where you see exactly giving data and making sure that the machine can give you the right response doesn't work. So this is what we will be learning today, is how we deal with text data. And this is exactly, I think this is common for every machine learning problem or every AI problem, is the key to any such thing is data. The what kind of data you feed into your machine or model, that is the kind of predictions it will give out. So even from a personal or from a human standpoint, from what information you have, from the kind of reviews you have read, or let's say from the kind of positive and negative comments which you have received about a particular item or somebody or something which you want to buy, you make a decision. You make an informed decision. So in here again, the input which you get into, which you process in your brain, and you take, okay, this is right for me. I want to pursue this particular career path, or I want to buy this model of phone. All of it is taken based on the data we receive, which is exactly true and same as to what happens um, in the NLP scenario. And this last line here is something which is very, very interesting, is with unlimited data and unlimited compute, we would have perfect NLP today, which we don't. And I don't think, so my personal opinion, this is that we cannot have perfect NLP, even in the near future. I mean, there is always some sort of, if you have perfect NLP or if you have a perfect ML model, it means we are replacing our own human brains, right? So, but yes, we can definitely improve, and we've improved quite a lot from where we started. And so, the more data we have collected, now that we have internet, we have IoT, smart things, we are able to collect more data, and we are able to make sure our algorithm learns and makes the right decisions and predicts it, correctly. But this is something which is very common, is the key to natural language processing is data. And just to add on, the key to any AI problem or any machine learning problem is data. So now that we've spoken so much about natural language processing and what it is and where it is, so let's just take a few examples as to where we see it on a daily basis. For somebody who doesn't know NLP, we all use NLP on a daily basis, right? So the first main and very common use case which has been researched a lot is sentiment analysis. Now, almost I think every single person in today's, in urban cities or everywhere, have a smartphone. Everybody is connected to the internet, and everybody has social media. I mean, each of us have a Facebook account, a Twitter account, an Instagram, so much. And this is just a small stat that almost 45% of the world's population is there on internet, and we all tweet, we all share our experiences. So we all, every single minute, if you see, that is, every single minute there are almost 500,000 tweets, which is a lot. So if you can imagine, if we can analyze these 500,000 tweets of every single minute of a day, the kind of inferences which we can come out with is huge. So I personally, all of us, I think we, before going to a restaurant before the COVID pandemic, we always check out, okay, is this restaurant good? What are the reviews? Somebody has already visited this. What are the best dishes? We always do this, and then we go. And then, or if you want to buy the latest OnePlus phone or the latest Samsung phone, we always read reviews. We read reviews in multiple sites, correct? So this is from the user point of view, that we all read reviews, what people have put. Now, how do companies view this? Companies on the other side, this is feedback for them. If, let's say, Samsung is releasing a model, and I think thousands and thousands of people use it and give feedback through about it through Twitter or through any other means. So people will use words like, the ease of use was great, which you can see here, right? Or I really like the user interface, or I didn't like a particular thing, I didn't like the customer support, or I didn't like how the search functionality is there. So each tweet, each review, a person cannot manually go through. So companies, most of the companies, and in fact a lot of people, use sentiment analysis, where you can extract the words, you can understand whether the sentiment is positive, whether the person is meaning it in a positive way, in a negative way, or they're just giving neutral responses. And a company can understand the flaws in a particular phone model or laptop model or anything, and they improve. Every model which comes out, every version of software or hardware which comes out, always improves. And how they do this is by reviews from all of us, and by analyzing the reviews by which all of us have done. So here you can see how they have, listed down the kind of different aspects of your model, and whether it is great or it is bad and it is good. So here is where sentiment analysis really helps. And even here, if you see Uber app, just to take an example, so people post, love the new Uber app, great job. So they know that this particular, the UI was great, right? So this is sentiment analysis, just another example here of airline Twitter sentiment. So people will understand what the company will understand, where which aspect of their industry or their thing that they need to focus on, and what is it, and during what time, when is it, which how many tweets are there, which year, which month, was there anything else which was happening during that time because of which there are a positive or a negative tweet, and what are the highest used words, flight and destination and all of it. So this is why what sentiment analysis really really helpful, and which we are also going to see today. The next very common use case and very important use case is a spell check. So we all have seen that whatever, whether be it a search engine, you enter a strong spelling like natural language processing. The search engine is able to automatically detect, in spite of the spelling mistake, as to is this the question. In fact, sometimes it doesn't even ask; it understands it so beautifully that it just shows result for natural language processing. Although I have made a lot of spelling mistakes in that, correct? So here, or let's say even in emails, of late, if you see in emails, when you type looking forward to, hearing, these are all standard sentences which we type when we email to one another, and the machine is able to understand that and saves your time by predicting that and completing the sentence for you. So a spell check and autocomplete is again, in the back end, there is a lot of natural language processing which happens. There are algorithms like Levenstein distance algorithm, where it detects as to how are the two strings similar, how are they dissimilar, can we predict this, or can we suggest this particular word for this error spelling. Just a few simple examples. One is Grammarly, you have Google Doc, and even we all use plagiarism detection for when we submit our research papers, right? It is able to go through thousands and thousands of papers and research papers, and able to detect that these are all the places where your where it is common and where it has been used. So all of this is natural language processing. The next one is what we can talk about is text mining, and this is very useful probably in the industry point of view. Like I said, you want to explore, you want to take out information from an encyclopedia, you want to take out information from a doctor's prescription, and or from some invoice or a bill which has come out. So the text mining is basically you are converting the entire unstructured data which is there and make it into a structured row column or a JSON or anything like that. So in every industry, all of us have text mining as a very important and a very useful tool. And there are packages like Python has a package for any use case. Probably one of the reasons why it has really helped all of us to implement these techniques. So you have PyPDF, you have PyDocs. These are all Python packages, open source libraries where you can read PDF documents. You can extract information from PDF documents, and you can summarize it. You can create a map. You can visualize it, and it basically, from a business or an industry standpoint, it will help you to summarize a 20 or 1,000 page document into, let's say, one page, and it will help you make better business data driven decisions. The next very common functionality is text classification. Okay, so this is again something which we see in our day-to-day life. Is your Gmail or any mail, Rediff mail or Yahoo or anything, it automatically understands or distributes based on primary email, social email, promotions, and some go into spam. So how does the machine understand that these mails are spam? So otherwise, initially, I still, when Gmail or when all these mail boxes came into picture, everything used to come in inbox. There was no segregation. So text classification is again is very important, and it's not just in mails. You can find text classification in customer support. If I give a feedback saying I don't like this product, it then automatically classifies it as a negative sentiment, or I like this product, so that becomes a positive. So you're classifying that sentence, or in this case even a document, into a particular label, right? So not just positive or negative, it can even be any label which you give. So you assign tags, you can assign categories, and there are a lot of machine learning and deep learning packages like fast text and flare which help you do this, right? And the most I think less researched, or in fact I think where there is a lot of scope, and the most difficult part of natural language processing is the machine translation. And so a very simple example of machine translation is, Google Translate, or any translation app for that matter. It is able to convert English to French, English to any language. So, and vice versa. So what you see here, this is very, very difficult because, like I told previously, each language has its own grammar, each language has its own structure and semantics and different meanings, and it differs. The way we speak English in India, the accent differs, or the way Americans speak the same language, it differs. The way people, Britishers, speak is different. So it's the same language but different, different use cases. Another simple example is you have the word organizer. We all use Z, whereas some people use S. It's the same word, and it means the same thing, but there are different things. So when you're able to translate, when you want to translate from one language to another, that is where you need to also understand what are the structure of the first language and what is the structure of the second language, and it needs to able to translate it correctly. So here is where you have neural networks and recurrent neural networks and LSTMs which come into picture, and machine translation is something which really people are working on to come up with, to really improve it. And a lot of Indian languages also have been, a lot of Indian based NLP tools and packages have also come, which help in doing all of this. So, like I mentioned, so we have all these techniques and applications and all of it. Now, Python is there. One main reason why this has helped people, to actually work on this is Python has a package for everything. It has for every small function there is already a package out there, which all you need to do is import it, call it, and you can use it to implement any of these functionalities. So just to get started, to give you an example, there are packages like Natural Language Toolkit, which is NLTK, very, very popularly used. There is TextBlob for pre-processing. There is Scikit-learn. Again, Scikit-learn is something which all of us have used if you want, if for machine learning purposes. There are deep learning based packages like FastText, which is from Facebook Research Lab. There is Flare. So all these are open source. Nothing is proprietary as such. And you have Spacey, Jensen, Stanford NLP. So each one is used for a different purpose. So each one, or most of them have same functionalities, but the algorithm which they use behind or the kind of response which you get differs. So based on your use case, you need to decide which package to use, which one is you are able to get better predictions or better responses. And with that, you can import it and understand, read the documents, and you can move forward, right? So just before we get into the natural language processing life cycle, I just want to know, so if you have any questions, I can take it up right now for the first part. And if you have any questions, just please feel free to type it in the chat box and I can uh, take it up as and when it comes. So do we have any questions till now? All right, okay. So I don't think I can see one. So we will next talk about what is the life cycle or basically the flow of natural language or the pipeline of NLP. And so this is a pipeline which is same to I think all ML problems. Is you first have data, and you have to have data in the form it can be processed. So that is why once you have data, once you have the corpus, you can process it. That is your text pre-processing and all kinds of. So this is where it differs. For language, there is a lot of processing which we need to do pre-processing, because somebody can express in emotions, emojis. A lot of nowadays, all of us use emojis and everything. So the machine has to. You need to kind of normalize all of these, and once you do that, you have exploratory data analysis where you can make certain recommendations and predictions, and where you're able to see how your data is basically exploratory, and where you're able to understand the kind of data you have, the maximum words which are there, or the most number of words used. The next part is where you extract relevant features from that particular data which you have created. So again, here you need to decide what kind of features are relevant to my use case, what features I need, what features are not needed. So that is basically feature engineering, and this is very important in NLPs because NLP is completely language data. So machine always understands 0 and 1. That is something which we cannot change, and that is something how it has been built. Machine is basically binary. It understands numbers. It doesn't understand hello, or it doesn't understand good morning. Now we need to find a way where you can translate the word hello or the word good morning or NLP into numbers, into vectors, and into certain formats where your machine can understand. And that is exactly what we do in feature engineering. And there are different ways to do that. There are different techniques to do that. And the next one is where you have modeling and pattern mining, prediction. You can use your own whatever algorithms. So the main thing in what do you say in NLP is to do the initial part, to process it, to understand it, and to extract the relevant features and convert it into the format where the machine can understand. Once that is done, then the next two parts are something which is common to all AI problems. You have algorithms, you have certain linear regression, logistic regression, you have SVM. So you have all kinds of things. Like, because once it is numbers, then you can use all of these, or vectors, then you can use all of these algorithms. So the first three stages is what is important, and then you deploy it. So this is moving forward. Now we'll go one by one. We will go as to how each of this is. And so basically, a machine learning model is as good as the data you feed it. So the first part is the pre-processing part, where we're going to talk about what is normalization. So you have the sentence, which is NLP is very interesting to learn. If you see here, you have abbreviations. You have interesting. You have the word I in capitals. You have exclamation marks. Now, When you are going to process it, what you need to do is you need to have one standard format which you can use across all documents and everything. So these are something which are very simple. And so first is, you before even you do any analysis or you do any feature engineering, you need to first normalize it. So few things which you can do is you can either convert it to uppercase or lowercase. You can convert, if you have numbers, like if you have two or three, you can convert it to words. And you can use, so these are the functions which you can use. If you are aware of string functions, you can use replace, reject. You can remove the white spaces, the punctuations, and all of it, and then you have this normalized form of the sentence. So this is something which everybody does. Now, what are the other pre-processing tools which we can do is, one is stop word removal. Now, when you have sentences like can listening be exhausting, or geeks for geeks, like for those where you have stop words. So there are a lot of articles like and the and to this. So all of these actually don't add value to your sentence. So they are important for constructing your sentence. But if you want to understand what the sentence is about, like the first line, we are talking about geeks for geeks. So these prepositions, articles, pronouns are not needed, and since they have no impact, what you can do is you can remove them from it so that your machine can understand what are the words which are important, and it can help take that into account. So again, this is something which is very domain specific and language specific. So you can create your own set of a function or a package or a file where you have stop words which you need to remove for. And especially now, so each one has its own pros and cons. Now when you say not is something again which will come under the stop word, whereas not is very very important when you're talking about I do not like this dish. So here not is very important because it adds value to your sentence. It brings in a negative emotion or a negative sentiment. So you need to be careful as to what are the words which you are removing, and you can customize it based on your use case. So when we work in industry, we have a lot of business jargon, industry jargons, domain. Like if I'm working in the retail industry or I'm working in banking industry, there are certain words which are very particular to that particular industry. So you need to be careful as to what you remove and what you don't remove. The next one is what is called as tokenization. So each word is basically, if you have a sentence, like for example, all work and no play makes Jack a dull boy. Now, if you tokenize, what tokenization does is basically it splits it word after word. Okay, it splits based on, let's say, a sentence or space or a comma or a full stop. So it depends on what you want to do. You want to tokenize it based on if it's a word tokenizing or if it's a sentence tokenizing. So there are different ways it does it. So the same sentence, if you see the first one and the second one, the output is different, right? So when you say sentence tokenizing, it does it using the full stop. So all the first sentence becomes one element, and the second sentence becomes the other. Whereas in the first example, you see it tokenizes word by word. So what you do, why we do this is because, like in this first sentence, you can see the word ALL and the word ALL repeating. Right here, you can, in this tokenizing, you can make out that the word all or the word work is being repeated twice. So it probably has a more higher importance, probably. Whereas here, you can't make that. So based on NLP is completely based on your use case. What is your use case, and what kind of tokenizing or featureizing or vectorizing which you have to use. But again, we need to be very careful when you do this, because if you have hyphens or parentheses, or let's say you have doctor. Now when you do tokenization, doctor, you have a full stop over there. That's how we write abbreviations. But if you remove that full stop, it dr standalone dr does not make sense. So you need to be very careful as to what you can what how you tokenize it, and you don't lose out on important information. So very simple, you can import it. NLTK already has a package. NLTK already has a functionality where you can just import it and call it and pass the data. And the next one is, in pre-processing, what we do is called stemming. these are two. These are stemming and lemmatization, which we have. Now, how they differ is when you have words like, let's say, playing, played, plays, all of them actually, the root word is play, right? So all of them actually are different terms, different verb, or the way you tell it, but they all have a common meaning of a person who is playing, or the word play. So what stemming does is it brings all of it to its root words. Like if you see here technology, the root word is technologue, but whereas the different ways you can use this word is technology, technologies, IES. So since all of them have the same meaning, why is it we don't need to actually treat them as separate words? So this helps to reduce the number of words which we need to feature, make features or create vectors, and it groups and it kind of brings all of them to its root words. But there is one main problem here is that it doesn't bring it down to a root word which is a proper English word. So if you see, it has is become HA, right? And technologue is again actually not a proper dictionary word. Obviously has become OBEIOU. So here there is one small problem. What happens is, let's say here, so when you have playing, PLAING, and you want to do stemming and you will get the answer as play. But when you have the word news, you will get, if you do stemming or if you call Porter stemmer, it will give you new. And they are not exactly root words. They are not similar because news is very different from new. So this is one of the places where stemming has a problem, and but this is again something which you need to decide, because stemming generally takes less time, less compute to give out results compared to the next one which we are going to talk about. So what it is basically is you have English stemmers, which is built on an English corpus. So all of this will only work when you have a corpus, and it is able to refer to that and then give out your root words. So since we saw that that example of news and new, so here lemmatization takes care of it. So what lemmatization does is it will ensure that your root words are also proper dictionary words. So if you just take an example here, like caring, if you do stemming, it will come down to car, and these two are very different in meaning. Whereas if you do lemmatization, it will understand, since it looks up on a dictionary. So it has a database. It is built on, lemmatizer is built on this WordNet. So there are different lemmatizers. This is just one example where you can use WordNet. All you need to do is you need to give the word, and you can get back the response. So what this one does is, for every word which you input, it will look up into the database, and then it will give you back the correct root word. But one main thing with lemmatization is, because it needs to do that for every word, the amount of time it takes and is much more than stemming. So again, based on your use case, you need to decide whether you want to use a stemmer or a lemmatizer. And so one thing with lemmatization is, although it will bring it down to your root word, but we use different words in different ways. So just to give you an example, book. I read this, or I am reading this book. Here you're taking book as a proper noun, where you're talking about it as as a novel or a fiction or something which you're reading. Whereas you can also say, I want to book a flight from Chennai to Hyderabad. So here your book becomes a verb. So the way your words are used in a sentence again is very important, and NLP needs to understand, your NLP, or whenever you are working, needs to understand where it is using what. So parts of speech tagging helps you to help you to detect which is a subject, which is a verb, which is an adverb or an adjective, and then help you make relevant decisions. And you can understand whether, if it's a noun, okay, we're talking about a fiction or a novel. Whereas if it's a verb, it needs to go and do something where you can book a flight. So this is where POS tagging, dependency parsing, all of these come into pictures, syntactic parsers, where you can understand the sentence or understand the word usage based on the neighbors, correct? So when I talk about neighbors, the next important word concept is n-grams. So like I mentioned previously, so in NLP or in language particularly, each word is related to the word previous to it, or related to the word after it. So the meaning comes only when you see the whole sentence as a whole. So what unigram, bigram, trigram is basically we are tokenizing based on, let's say unigram is 1, bigram is 2, and trigram is 3, and so you can move on. There are n grams. So when you just say this is big, individually it doesn't make sense. But when you do a bigram, you can understand that we're talking about big data, or we're talking about an AI book. And when you see trigram again, it really makes more sense. So when you are trying to understand what kind of language or what kind of corpus you're working on, n-grams are really helpful, and in fact n-grams are sent as your parameters to a lot of your models, so that the tokenization or the machine will understand that okay, we need to break it into three words, or three tokens per this thing. So that is why n-grams are really helpful. And so basically, if you have trigram is when you have a lot of data, and bigram is generally used when you have smaller data. And so that is again based on your use case. So this was completely about pre-processing. And the next major part is what we call as feature engineering. So this is where, if you see, we will be converting the bag of, we will be converting the words into numbers or vectors. Now, let's say you have two documents. Document one, you have I love dogs, and the second sentence is, I hate dogs and knitting, and the third one is, knitting is my hobby, or knitting is my passion. So what we do here is, the first one is what we call as, you can call it as anything, document term, one hot encoding, bag of words, is you give one, whenever there is an occurrence of a particular word, it is mapped as one. So this particular one becomes 111 and then 00000. Whereas here, your word my, it's repeated twice. So then that's why you have two. But in this, what happens, this is a very useful way, but what really happens is, the frequency, or the meaning is lost. Now, unless and until, or the context which is there is lost, and again we have the problem of stop words. Now let's say, now my actually doesn't really make sense, or is of importance in this sentence. The words which are of importance is words like love or dogs and knitting and hobby. These are words which are important, and these are words which need to have a more higher representation in your model. But what you see here is my has a higher representation, and even words like I or and have the same representation as the others. So this is where your stop words, which we learned previously, is very important. Is because you remove all of that from your corpus, and this is where we also have another concept which is called as TF-IDF, which is a little better compared to this. But you can always use bag of words one hot encoding, because one is, it is easier, and it really it helps you to get started, and start with how the machine will able to understand all of this. So next we come up to is what we call as term frequency and inverse document frequency. Now, like I explained for the previous one, the words like hate and is and hobby and passion. So there are some words which are very common in your, which are very commonly used in a document. Articles are commonly used in a document. Now, how will you differentiate between a document one and a document two? The differentiation will only happen in those words which are unique to a particular document, not the words which are same, or not the words which have been repeated in both the documents, right? So this is exactly what TF-IDF helps you do. So it is basically a simple mathematical, it is a number, a statistic, a numerical statistic. What it does is it multiplies. So TF is the bag of words which we learned previously, right? And what IDF does is it measures the importance of the term. So it will help you do how many documents are there, total number of documents, and what are the how many documents contain this particular word. So you take a logarithmic function of that, and then you multiply it with the bag of words. So here what it is helping you to do is, you're able to extract which word is important, the importance of the word in across the different documents which are there. So if you see here, for example, what it is if you have a number closer to zero, the more common the word is. So if you see 0.18, I has 0.18, dogs is 0.18. So that is something which is very common across document 1, 2, 3. Whereas something like hobby or passion or the word my is very unique to a particular document, or it is not repeated. So that is why if you see, these are something which are rare. They are not as common as the other words. So in this you can make out what are the important words, and then you can make your assumptions or analysis or all of it. So this is again TF idea which is there, and the next one which has really helped to create, in fact, help people in the industry and to make better predictions or better embeddings. One is which is called as word vectors. Now, what word vectors really does is, you have, let's say you take this map, or this graph which is there. It converts, it converts your words, or how to plot your data frame. If you have a word like this, it will convert it into vectors, and it will convert. So basically, you convert it to numerical form, and based on the context and based on similarity, it is able to group. It is able to group. So when you say, let's say, there are sentences which have meeting. So if you see here, all words which are related to that, meeting, meet, hold, Wednesday, March. So all of that are the vectors of those will be similar. So they are all grouped together. So here you are able to detect, how similar your words are. So so based on your previous word, based on, so that's what these two things do. Skipgram and Seaborg, it predicts the current word with the help of neighboring words, and Skipgram is it predicts neighboring words based on your current word. And then you are able to group it, all word vectors, all words which have similar word vectors are grouped together, like film, actor, award, prize. So although these are all different words, they are all grouped together since they have similar, since they're all similar, right? So this is something. So word vectors and word embeddings is something which has really helped us also in the industry to process sentences and make help the model to better understand. So these are all the feature engineering and the data tree, text tree processing which are there. And if you would like to try and implement all of these, I can. So I have a set of a tutorial kind of thing where we can go through. So if you would like to also do it, so I can share the tutorial with Sir, and the code is already there. So you can, if you have Jupyter Notebook, you can install the relevant packages, and you can try it out yourself. So okay, so I have a few questions here. So I will take off. I can take questions before we get started with the hands-on. So there is one. What is the use of Anaconda? Okay, so Anaconda is just like a tool or an IDE. So it gives you a platform where you can, let's say, implement your scripts, right? So personally, I use, so you have editors. Okay, you can write your code and you can run your code. Now, very simple. You can even run your code in command prompt. All you need to do is Python filename.py, right? What Anaconda does is, it already has inbuilt Python. It has certain packages which are already inbuilt. Okay, it gives you a platform. It gives you a tool where you can use your run your Python program, and you can, instead of you have to specifically invoke it. So that's why you use Anaconda. It's very helpful for people who want to get started with. So all you need to do is, if you want to install a new package, you can do conda install and you can do it. Or you can also use it using normal pip install, and you can install packages. Correct. So Anaconda is nothing specific to, let's say, a particular language or anything. It is a platform which, or it's an IDE, or it is, it basically, it helps you software. It helps you to run your Python code. And what is meant by pattern mining? Okay, so I think text mining and pattern mining are pretty similar. So, I mean, we covered this. So, mining is basically what you have data. Now, what kind of data are you mining? As simple as that. If you're mining, let's say from a text document or from dictionaries or encyclopedias, you are coming up with certain. You are summarizing text. You are summarizing the words which are there. Pattern is you are kind of detecting what are the patterns which are there, what is the trends which are there. So if you see the airline example which I took, so that is completely where you are coming up with patterns. You are predicting patterns, you are predicting forecasts. So all of that comes under you are doing something like pattern mining. Okay, there is one more which is merits and demerits of this topic. NLP, okay, so merits are definitely what we have all seen. The applications are all merits. Demerits is something I think I would personally say is you can't really let's say you are building a chatbot, or if you are using you're making certain predictions based on your machine. Like I said, your machine will only predict based on the kind of data you have. So let's say the data which you fed it itself is wrong. Okay, and so your predictions will be wrong. And let's say you are making some decisions, okay, you're taking some actions based on those predictions, then that is something which is a drawback. So NLP will only help. So NLP helps you in a long way. It helps you automate. It helps your life be easier. But you can definitely not, replace humans with natural language processing. Very similar example, now Alexa is mimicking everything. If I tell to Alexa play this song, or if I say tune into this channel, it's able to do. But there are certain times when Alexa doesn't understand, right? So it is so basically, yeah, demer, that is one. And second thing is, um, you need to use it with caution. I think that is something which everybody, all AI and all ML researchers who have worked on this field have also been telling that um, you cannot have machines to be more intelligent. So I don't know how many, if you have seen this movie I Robot, it's a very practical example of the demerits of this topic. That is where the machine understands so much that it kind of self evolves. Even things which you are not given, even the data which you have not fed it in, the robo will start making its own decisions, and that is something which is very which is not favorable. So yeah, that is one. Second is NLP. Is it like programming language, or is it a different programming language? No, NLP is not a programming language. NLP is a domain, or it is a concept. The programming language which you use to implement the concepts is Python. Although you can use other things, but Python is the most common programming language which is used. I think to give you that example, just to make you understand, I can share my screen which has the code, and you will sentiment analysis. Okay, is my screen visible? Yes, I think it's visible. Yes. So if you see, NLP is a domain, or it is an area. But what you actually do is, the language which you use to implement that or to do is Python. So for all of you who know Python, this is how you work on it. So I can share this and you can try it out, but I can just go through a very common use case which is there. And so the first thing is, okay, so what really we discussed was sentiment analysis, right? So what we do here is, you have all these packages. So these are all the packages which we had explored. We have NumPy, Pandas, scikit-learn, NLTK, text blob. So these are all the packages which we saw. So Python helps you because you just have to import these packages, import these functions, and you can get started. So the first thing what you do is, okay, let's run this. Okay. So the first thing what you do is, train, you basically, I think, yeah. So when you have star, it means it's still running. Okay. I'll keep explaining because some you will see the compute time also and how long it takes also. So the first thing what you do is you need to import your data set. Now I think I can 1 minute. I can first show you the data set which is there, or if you can actually see it here also. So the first thing is I have a data set which is called IMDb dataset.csv. So let me see if I can just pull that up. So you will understand how what is the data and how are we really processing it. Yes. Okay. Let me just stop sharing. Okay. Um, is my screen visible? All right. IMDb dataset. Okay. So what you see here is almost some 50,000 sentences, and they are labeled. So when I say labeled, it means you are actually mapping each sentence to a particular sentiment. You are already giving this data. So it is called a supervised learning, correct? So what you see here is one of the reviews mentioned that if you watch this movie, they are right, as this is exactly what happened with me. So if you see here, this is a positive review. So, and then, but if you also see there are, let's say there are number one, then there are some capitals, there are you, there is this apostrophe, you will be basically you all, and you have hyperlinks like /br, HTML tags. So you have like this data set which has lot of, okay, see, for example, in this one you have stars, and here you have parentheses, here you have capitals. So a data can be all in all sorts of ways, and you're already giving that these data is positive, this data is negative, correct? So this is our data set, and if you see, okay, I can just pull this down. So you have like, this is, I took it from the internet, it's a publicly available data set, so you can try it yourself also. See here, so you have almost 50,000 data reviews, where each of that is mapped to a particular emotion: negative, positive, negative, positive, correct? Save. All right. So now we can go with, now that you have seen the data, we can share screen. Oh, sorry, not this. Sorry. Sentiment analysis. All right. I hope it's visible now. Yep. So now that you've seen the data, we are basically inputting the data. Okay, the pandas is you are able to read that particular CSV file, and this basically shape gives you the number of rows and number of columns. So you have 50,000 data, the lines and sentiments, and you have two columns, which is review and sentiment. And I'm just printing the top 10. So if you can just see, they are positive, negative, positive, negative. Now, and also one major thing is you should see that your data should be balanced. So let's just run this. If you run this, you'll see, okay, so you get an output of 50,002. The next thing which you have to see is your sentiment, and you're counting the number of positives and the negatives, which is, yeah. Yeah. So if you see here, it is a balanced data set. So you have 25,000 reviews which are positive, 25,000 reviews which are negative. You should always have a balanced data set, because let's say you have an imbalanced, if you have 49,000 positive and 10,000 or 1,000 negative, then obviously your model will understand that most of it is positive. So you might not get your necessary, let's say, your response. So once you do that, you have to first split your data set into training and test. Okay, now this is very important, because you need to check whether your model is predicted correctly. Okay, you need to check if so you need to give certain input after your model has been built. So what we generally do is, so we had 50,000, so we are here dividing it to 40,000, and the first 40,000. So that's why you have colon 40,000, and here think, yeah, I think this is better. And here you are taking the last remaining 10,000 as your test data set, right? So once we do that, so if you see here, we are printing the shape. So when you print shape, you're getting 40,000 and 10,000. So the next one, what you have to do is the main thing is one is so there are different uh, ways you can do it. You can since they're all string, no, you can use regex. So I'm giving certain patterns. I'm giving certain patterns saying that please remove all these unnecessary things. So if you do that and you pass, and I'm replacing these with space. And what this one does is beautiful soup is we had mentioned that there were a lot of BR hyphen like arrow BR kind of HTML tags. So what this one does is it removes all of that. It strips all the HTML ones, and this is a function where you are just calling these two functions and you are applying that to your review. So your review column, if you see now, has removed all of the parentheses and all these other HTML tags and all of it. Correct? So this is all the text pre-processing which we learned. So we come here. Next is we remove the special characters. Now special characters can be many. Now you have you can have colon, you can have slash, question mark, left arrow, greater arrow. So all of that really doesn't is not needed. So instead of removing each one, what we are doing using regex is we are giving a pattern. So this pattern states that we only need letters which are from small a to z, from another a to z, and then 0 to 9, right? So I think this has to be capital A to Z. Okay, so that is something which we are doing, and then we are converting that into. So you will only find these. You won't find numbers. Sorry, you won't find any other special characters like full stop or comma or anything else. That is something which we do using text pre-processing. So all this comes under the normalization aspect. Next one is what we read about stemming, correct? So if I will run it now itself, because you will see the amount of time it takes. So as and when till the time it is started, it's continuously running. So what stemmer does is what you see here is it takes each of this string, it splits it into each into individual word, and then you can invoke this stemmer. So stemmer is an English, what you say, is an English stemmer which is built on a corpus. So it's still running. So in a live industry application, you can't have such delays. So imagine you're typing something to your chatbot and your chatbot replies to you after 10 seconds or after 20 seconds. That is not at all favorable actually. So the response time needs to be 1 second. So that is where you need to work on how we can make this faster. So till the time that runs, I will explain to you about stop words, removing stop words and tokenizing. So you first tokenize, and what you do here is, if you see, you are calling the tokenizer, you're sending the text, which is your input, and so based on each one, you are, filtered token. This is like a list comprehension. So for those of you who are aware, like who have worked on Python, these are all things which you will learn, so you can definitely implement it. And so what you do is basically you are removing, okay, you are removing all those stop words, and then you're tokenizing each of it. So if you see here, one review, you can't see any a and the, so this is the final response after stop words, right? So, and I think the stemmer is still running. Yeah, yeah, the stemmer is still running, so we will wait for that to finish. So what it so the next one, once you have done all of this, you are basically, you have normalized it, and then you're taking the first 40,000, right? These are the train. So these are all the normalized train and the normalized test. So just to give you an example, if you see, it is all cleaned up now completely. You don't have any other extra unnecessary things. Now, what you need to be very careful is whatever pre-processing which you are doing, all of these, to for your model. Let's say you get an input from the user, you have to do the same pre-processing for that also before you feed it into the model. So even your test reviews also have to have the same pre-processing which has been done. Okay, so you cannot give things which are where you have exclamation and at the rate and all of it, because your model will not understand since you have removed it. So that is something which you need to keep in mind. And I think this timer is still running. So then we can move on to what we first saw as bag of words. Correct? So we'll be seeing two things. We'll be seeing bag of words and we'll be seeing TF-IDF. So here what you see is we are importing, a count vectorizer. We are importing that. We are giving the n-gram range. We are giving other parameters. So this is something which is, you are basically converting your the words into ones and zeros. Okay, that was what we saw in previous bag of words model. So you have train, you have test. You are giving the train. You are transforming it. You are giving the test. You are transforming it, and you are printing as to what are the reviews and what are the shades. So if we had 40,000, but here if you see that 40,000 has been expanded because now you're converting it to numbers. So this is the feature engineering part. And the next one is what we also saw was TF-IDF, the term frequency and inverse document frequency, correct? So one minute, why is this- okay, so we'll allow this to happen. Nine, yeah. Okay, so normalized test was over, bag of words is over, TF-IDF is over. So now what you do is, so this is we have converted your review part, correct? All our reviews have been converted. Now next we need to also convert our predicted value, like our sentiment, which was positive and negative. Even that needs to be converted into zeros and ones, correct? So what this one does is label binarizer. Okay, so what this, so you have to create, invoke this, call it, and then send it. So what this one does is positive becomes 1, negative becomes 0. So you basically convert that also to numbers, and you are splitting that also. You're splitting 40,000 here, and you're splitting from 40,000 to 50,000. So first 40,000 and first 50,000. So if you see 111, these are all positive sentiments. If you see 000, these are all negative sentiments, right? So this is where your feature engineering part is done, and where you are split it into training and test. So the next part is for anybody who is already into machine learning. So each one actually, so I'm not going to explain what logistic and what each one does, because this itself is another 1 hour tutorial. But what you do is you call your machine learning models. So this is very, I'm not explaining this because this is common to all machine learning problems. This is something which is not specific to NLP. So since now you have converted into words and converted it into numbers or vectors, you can now call your logistic regression model. You can give the number of epochs, you can give your train review, train sentiments, you can give all of it. And so we are giving both. We are trying for back of words also. We are sending for TF-IDF, and then you get back. So this is the response which you get back, and now their model has been built after this. Okay, yeah, I think the stemming is done. 1 minute. Remove special characters, yes. So if you see, our stemming is over. So it took such a long time for us to actually do this. So we will now do the others. So tokenizer is done, and so we will now be, so we have started this, and all right. So just going back to what we were discussing. So you have this. So you are basically calling this machine learning algorithm. Okay, and your model creates here, and what you do is you predict. So now what CV test reviews and what TV test reviews does is the last 10,000 reviews which you had selected as your test data, you put that in your prediction. You run that particular model and you see whether it is predicting it correct or not. So these are all the predictions which are there. So almost 10,000 predictions which are either in the form of 0 and 1, 0 and 1, correct? And so just to give you an example of what has been predicted is, I'm just giving you the top 5 and the last 5. So if you see, the last 5 are the ones which are test data. So you have this particular, and then it is given it as whether it is positive or negative and all of it. And this one, the next part, once you do it, you can also check the accuracy. How do you know how many have been corrected, how many have been predicted correctly, and how many have been predicted wrong? So accuracy score is a function where you give your test sentiments and you give your model, and it is able to predict. So what you see here is For bag of words, you again have 75%, 75.12, and for TF-IDF, you have 75%. So these are all various metrics which you can understand as to, you have true positive, true negatives, you have precision, recall, score, how you understand what are the sentiments which are wrong. So this will help you to improve your training data. And so this is a complete classification report of the first model which we used and the second model which we used. So this is for one algorithm. Like this, you can try for different algorithms. You can try, you can print your, you can use name-based algorithm. So these are something where this particular precision recall F1 score, all these numbers and the way this is generated is common to all machine learning problems. Even if you have a data set which is numerical, let's say with numbers, so even that you can use, you use the same algorithm, but you have to obviously give your input like test sentiments and all of this in that particular format. So you can also print your, confusion matrix. So this is where you have true positive, true negative, and false positive, false negative. So these are, these are different other algorithms which are there, multinomial name-based bag of words. So for different algorithm, so this is something I've already run. So if you see there is a slight increase, there is 75, 75.1, 75.09. So you can, so these are few of the algorithms which are there, and this is something which I wanted to explore is a word cloud. So when you talk about mining and when you talk, somebody had a question also, and you want to know what are the major words which have been used in all of these. Is you can visualize and see that, okay, so these are the positive, positive words that have been used in the reviews. Let's say product, realism. So whenever you have a positive review, these were all the terms which were used, and these are all the negative words. Okay, so if you see worst and probably something which is not good, so forward. So whenever I think the pace was not good or there was a mistake over here, so you can get an analysis as to how your reviews are. So I think this one. So this is a complete. If you wanted to understand, so basically, finally, what you get back is from a person who wants to understand what it is. You run this algorithm, you create your model, and you predict it. As simple. You load your data set, you do pre-processing, you do feature engineering, you will pass that into your machine learning model, which is for here we are using logistic regression. You give your training data set and both x and y. So you give train, you give, and then you, based on the model which is created, you enter a particular statement which is your last one, and it gives out the 0 and 1. Now to see which one is 0 and which one is 1, we are printing the last 5, just to give you an example that, okay, so the model has now has told you that these are backplot dialogues, so it is a negative, correct? So, this is something which you see in backend. Now, when you see from a front end point of view, you will not see all of this happening. From a front end point of view, after this, what you do is if you have 0 and 1, all you need to do is you will write a logic where you say if sentiment is equal to 0, you will display to the user saying your sentiment is negative. And if you find 1, you will you will give back the response to the user saying that your sentiment was the sentiment or the Twitter feed or the tweet which you entered is a positive tweet. So from a backend point of view, we will only work with this. But if you want to convert this into an application and demonstrate it, you have to add a Python script where you take this 0 and you convert it and you would say that, okay, this is what is negative and this is what is positive. So I think that is pretty much it. So this is, to start off with, this is a lot because you have to understand what each one does, bag of words. But this is one of the simplest examples for you to get started with with sentiment analysis or with natural language processing. So we finished text stemming, we finished this, we finished tokenizer. So I think, yeah. So when I do, so Jupyter Notebook really helps you to enter it, run cell by cell. So here I'm actually running cell by cell now. So bag of words we saw, and count vectorizer. So this is a running code, and it will help you convert, and you will basically get the same response which you saw previously. It's just that based on what the technologies you use and terminologies you use, you will the time it takes is there. So that is pretty much it with sentiments. And I can stop sharing. I so I have a few questions here. Okay, it is and it is used for final year project. Okay, so I am not sure what the question is here, but yes, I mean it's a technique, it's a domain, and if you want to work on a project, like let's say sentiment analysis itself, if you want to work on a sentiment analysis project, which and you will definitely use NLP in that, so you can take that up as your final year project. So NLP is it's a domain. The project what you use. So like like we discussed sentiment analysis, we discussed text classification, chatbots. So that becomes your project, and the technology which you use becomes NLP. Okay, what is the best ratio of training and test data set in NLP? All right, so there is nothing as best ratio because it is a recommended ratio is what 80/20 is what we do, 80% of train and 20% of test, but it is not something which is fixed. You can obviously modify it, and it is better to modify it based on your training data, but just make sure that your 20% of your test data doesn't have only one label. Let's say your test data should also have all kinds of um, you know inputs and all kinds of labels. If you're having positive and negative, it should have positive and negative, so that you're able to your accuracy and your classification, the report which comes in makes sense. So the default ratio, which if you import scikit-learn, let's say you import that package, there is a function called as train test split. So that does it as 80/20. So that's the recommended, that's the default. Can you answer once again why we use stemming instead of lemmatization? So we call it as lemmatization. Stemming is used because it is less, it takes very less time. It doesn't take as much time as lemmatization, because what lemmatization does is it goes and it checks if the root word is a correct word. So for if you have now let's say we took this IMDb data set. Okay, we had 50,000 strings, and in 50,000 strings we had at least on an average we had 20 words per row. So if each of this, each of your thing has to go into, let's say, um, each of this has to go into your dictionary or your and it has to check that if it's a correct word or not, so much time it is going to take, correct? So that is something where you use stemming, is because it is much faster, and you are able to get the same thing. We will use Python language in Jupyter. I don't think we can use any other programming language in Jupyter. Yes, I think I'm not sure if it is supporting R. You do have R Studio, but yes, Python language is definitely you can use in Jupyter. So Anaconda you can. So I just explained to you in Jupyter because it's easier to run it like cell by cell, and you don't need to um, write a complete Python package and print it and see. So that is something why Jupyter is helpful. You can even use Google Colab, you can use Anaconda, and even in Anaconda, because you have to write a complete script, you have to put print statements and then you run it, and then you get the response in a shell. But what we saw here is there were a lot of individually we could see each two lines you could see. So that's why Jupyter notebook helps. So that is why we use Jupyter. And but if you're looking for IDEs, there are plenty of IDEs. There is PyCharm, there is Spider. You can use Sublime Text. Editors you can use a lot, but there are pre-built like PyCharm and Anaconda and all of it. So all of them do the same thing. What really matters is the Python version you work on, like 3.7 or 2. 2 is deprecated, so everybody is now working has to work on 3 point version. So The platform which you use doesn't matter. It's just that what you need to understand in NLP is basically there are so many algorithms, there are so many methods. Not one method is the right method or the correct one. So, like somebody said, why are we using stemming lemmatization? Somebody can argue saying stemming doesn't give the right root word. So, why are we using it? So maybe for somebody, for some industry use case, you don't have a necessity where you need the right root word. You are able to get the same response, same prediction, or same thing using stemming. So why should one use lemmatization? Correct. So it is dependent on use case. If you have a retail use case, if you have medical or a healthcare use case, medical terminologies will come into picture. Some medical terms might not even be English words. So that is where the challenge is, that you need to build a domain specific application or a project. Another question is, are any other challenging application yet to be worked on? So there is nothing like yet to be worked on. There are a lot of I think a lot of progress has been done. Now the main thing, okay, so one thing I can give an answer to you is the NLP whole thing is actually three parts. The first part is natural language understanding. The second part is natural language processing. And the third part is natural language generation. Now, what we have seen is natural language understanding, which is NLU, and we have seen what NLP is. NLU is where you can read. You make the machine to understand what is there. You don't do any processing on it. You don't do any features. You don't extract. You don't predict if it is positive, negative, nothing of that sort, right? So that is what we have been doing NLU and NLP. Now, natural language generation is when the machine can itself generate responses on its own. It is not something which we feed in. So that is something. Most of these machine learning things is we give the input, we give the output also. For a chatbot example also, so what we do is we give the, okay, I can just to make you, just to help you understand. 1 minute. You will, the generation part I think comes there. I did have slides. So, see, like for example, when you asked, I can. Okay. So I did have a few slides on chatbot, but I think we are, we don't have much time, so I can just explain this part since that question was asked as to. Okay, sorry. Um, So I'll explain this. When you say something, when you say what is something which is yet to be worked on, is this. This is not just chatbot based. This is for any machine learning or any AI application. Whenever you have a closed domain, and let's say you are working only on a travel industry application or a retail industry application, and you are giving rules. If A, then B, or if B, then this action. So that is a closed domain and retrieval based. So this is very easy, correct? So the next one is, let's say, a smart machine. So you have a closed domain. So your algorithm or your machine learning model will only help in for a retail use case or for a medical use case. So your domain is closed. Okay. So there, but you are doing it generative based. So here you are not giving any if else. So what we saw, sentiment analysis is not if else. So sentiment analysis comes here. So you have built a smart machine because you are not giving if string is, if this is the string, then enter A or enter positive or enter negative, right? So that is where it is. So this is something which we have started to explore. The next one is when you have an open domain. Can you have one application which will handle definitions, which will handle everything? When you have an open domain, our humans is, so we humans are here. You can ask us about anything. You can ask us about any math, science, medical, health, any industry you take. Our domain is open. We are able to process information, and we are not fixed on one thing. So when you do open domain, okay, and when you do generative based, it is still, so here is where most of the current people are exploring, which is general AI, which is the hardest, and this is where humans are, and we are trying to go from one aspect to another. So I hope that answers your question. And is there any other? I think that's it. Yes. So I think I've answered all your queries. And so thank you so much. And I hope, I just have one last thing to share. It's the last slide. So just to conclude that, all right. So basically, yes. So NLP has helped has helped all of us to, make machines our best friends. We are able to talk to them. We are able to interact with them, and we're able to not just we're able to understand, read, decipher, and we're able to make an analysis and all of it. So NLP has really helped us to help machines to understand what we do, right? So questions is something which I've already taken. And if you want to explore further, you can reach out to me on LinkedIn or Twitter or GitHub. And if you want the slides are put up on the GitHub repo, so you can go and have a look at that. And I will also be sharing it to Suresh sir or the CH, to the college team, where they can share it with all the attendees. So thank you so much, and I hope this really helped, and I hope this gave you a window as to what natural language processing is.
Thank you, ma'am. Are you able to hear me?
Yes, sir, I can hear you.
Uh, it's wonderful session, ma'am. Your presentation is very nice and clear and knowledgeable. Hands-on is very nice, and your answers also very good for the questions raised. And the participants are also very satisfied with your
Thank
presentation.
you.
Okay, I thank our management, our principal, our HOD, and our coordinators and other supporting staffs and other colleagues. Okay, uh, for supporting this webinar as a very successful session. Okay, ma'am.
Thank you,
Shall we
sir.
have it? Thank you,
Thank
ma'am.
you, team. Thank you, everybody, for having me here.
Yeah. Thank you for all the participants. I'll end up this session. Uh, Thank you. And one more thing, participants are requested to fill the feedback form. Then only you are able to get the certificates. It will be received within the 3 working days. Otherwise, you can mail me freely. You can feel free that you may raise any questions regarding the certificates if it is not received. Thank you. Thank you all. Ma'am, are you in the line? Uh,
Yes, sir. Are we done with the session?